All right, angle of elevation and angle of depression. We talked about this a little bit last week. Angle of elevation is where we're looking up. You're looking up. Angle of elevation is if you're looking down, like into a depression in the ground. Or elevation, you're looking up at an elevator as it goes up. So that's angle of elevation, that's angle of depression. Are they the same measure? Yes, they are. Because so I've got someone up here, and they're looking down at me, but I'm down here. So they're looking down at me, but I'm looking up at them. These angles are alternate interior. So they're really the same angle, just the question is, are you looking up or down? So we're going to do two problems here. The first one. So this is highly realistic. I walked outside and I looked up 72 degrees, angle of elevation, and I saw a UFO flying in the air. And the UFO was trying to beam up my cat. My cat's name is Kitty. And so I get my rocket launcher. I'm like, oh, I'm going to launch the rocket up it. Oh, crap. I don't know how high up it is because my rocket launcher will only go 70 feet. So we got to figure out how high the spacecraft is. So I do some math in my head real fast. I'm like, okay, my eyes are 6 feet off the ground. I'm 20 feet away from Kitty. Oh, I got to do a trig problem here. Okay, so I'm going to have to find out how tall it is up here. But to find the whole height, I'm going to have to add on my eyes. Okay, no problem, no problem. I got this. First, how much is x? Everybody shout it out. 1, 2, 3. 20 feet. Yes, because this is a rectangle, isn't it? You see the rectangle, don't you? And if that's 20, that means this over here is 6 feet from here to here, right? So we just have to find out what y is in order to find h. No problem. If this is 20, that's y, we've got 72 degrees. What two sides are we using? What two sides are we using? Sir? Opposite and adjacent. And according to Self-Catello, what are we going to use, sir? Tangent. So we set it up. The tangent of 72 degrees is equal to y over 20. Put that over 1, and we cross multiply. Y times 1 is equal to 20 times the tangent of 72. So we look on here. 20 times tangent of 72. Throw your hands up like the ceiling can't hold us. If you got 61.55, 3, 6, 7, blah blah blah. Yes? Woo! You rock. So that's 61.55. This is 61.55 just for that triangle. So how tall, how high up in the air is the alien spacecraft? Sir?
6, 8, 7 feet.
Yeah, this is 61.55. This is, but my eyes are 6 feet off the ground. So how tall is the whole spacecraft? Gotta add that and that. 61.55 plus 6 is 67.55. So will my rocket launcher get up to destroy the alien spacecraft? It goes 70 feet. Yes, it will. We're good. Great. So my kitty is safe. Real life example? Well, maybe not with a UFO. But finding how tall something is? Yes. For example, let's say I'm like, hey, let's pretend this is just a light for a second. It's kind of swaying back and forth. I'm like, okay, can I, because it's broken a little bit. Car hit it. Swaying back and forth. Should I park my car here? Should I park my car here? Why not? It's 61 feet tall, right? If I park my car here, will it come over and crash on my car? How do you know? It's more than 20, isn't it? All right, great. So could this be used to figure out, hey, my tree's getting kind of old. I gotta check to see if it's gonna fall on my house or something. Could be important, right? All right, this is like what we did on Friday. Got a ramp, we gotta figure out the angle of elevation for it. Figure out the angle of elevation for it. Oh, give me answer. Well, we measured from here to here, using the bricks, that's 6 feet, this was 31 feet. This side, I forgot and left the answer up there. Because it's a rectangle, that's obviously going to be 6 feet, isn't it? So the x is 6 feet. Set up a proportion to solve for theta. I will give you 20 seconds. Go. Three, 2, 1, my turn. It says Spinoza.
Would it be sine?
Mm-hmm.
Sine of 90, or is it theta? The sine of theta
Sine of theta.
equals 6 over 31.
6 over 31. You are correct. From theta, this is the opposite side. That's the hypotenuse. Hypotenuse is always crossing 90. That's crossing the angle. So how do we get rid of sine there? How do we get rid of sine, Ms. Anderson? Arc sine, or the inverse sine. Do the inverse sine to both sides. So theta is the inverse sine, 6 over 31. All right, use your calculator. Mr. Cups, you get it?
Not yet.
Okay. Give you a second here. Six divided by 31. There you go. So I hit inverse sine, 6 divided by 31, and you get, sir?
11.15993687.
11.1599.
36872185.
All right. There you go. That's how you find the angle of elevation. So this ramp's going 11.159 degrees up. From Friday, on that worksheet we did, do you remember what the angle of elevation for a ramp built to code is? Handicap ramp. Not 12. What? No. It's it's like 4.76 something degrees. Yeah. The pitch was 1/12. Pitch was 1 to 12. Yes. Pitches rise over run. They said 1 to 12, so the angle is 4.76 degrees. Is our ramp here handicap accessible? No, not even close, is it? We're way too steep. 11 degrees. People going up the ramp are going to end up falling backwards. That's no good. All right? You don't want grandma falling backwards when she's going up in her chair. Okay? Now, just because it's not built to code currently does that mean it wasn't built to code 50 years ago? No, it might have been built to code 50 years ago, but things have changed over time. Things have changed. Just like electricity. In electricity, you have, the new code is you have to have those ground fault interrupters in the bathroom. You know those light sockets with a button on it? Keep from getting electrocuted? But do they have those now? How many of your bathrooms have that? Okay, a couple of you. So does that mean everyone else, you have to completely redo the wiring to get those? No, unless you're going to update your bathroom. Then you have to bring it up to code. So that's how, like our ramp down there, it might not have been built to code, might not currently be up to code, but it was built to code years ago. So if we ever want to update the building and update that part, then we have to fix that. Otherwise, we just leave it as is. Angle of elevation, angle of depression. So basically what we're doing just like we were before, but it's more of real life problems. More real life problems. Questions? Okay.